As it is being displayed, what is computer graphics? It is nothing but drawing of pictures, lines, charts, etc. on the computer screen with the help of some programming languages. In the laboratory, we'll be using C programming languages here. I can define computer graphics in another form, which is nothing but a process of generating, manipulating, storing, and displaying graphic objects. Some of the examples are pictures, charts, graphs, diagrams, etc. This is nothing but a simple definition of computer graphics, which is also an important question for your internals as well as externals. In computer graphics, basically objects are presented as collection of picture elements, where we call that picture element as pixel. If if in the question in the internals or externals, if there is a question called what is a pixel, it is nothing but a collection of picture elements. You can say, okay, this might be a part of your question, that is nothing but define pixel. You should define the pixel as it is nothing but a collection of picture elements. So this is the basic introduction of computer graphics. That is nothing but definition of computer graphics. And to additional for the definition of pixel, that is nothing but a pixel is a smallest screen element which is being used in defining a picture. Clear? So some of the basics, that is nothing but advantages of computer graphics. As I told you, some of the advantages before some days while explaining module one, some of the advantages are high quality graphic displays. That is nothing but you get a higher quality on your display. That is nothing but on your computer. And it provides some of the tools so that you can produce some kind of graphs, pictures, etc. And then for animations, and then producing 2D, 3D, or so on, different simulators. Then using motion dynamics tools, that is nothing but advanced tools you can use with the help of graphics, that is nothing but computer graphics, so that you can, if suppose an object is being visible to you, you want to move that object into the screen. With the help of computer graphics, you can do that with advanced tools there. These are some of the advantages of computer graphics. Then some dynamics you use so that it is possible to change the shape, color, as well as other properties of that particular object. So these are some of the advantages of computer graphics there. Then applications of computer graphics. We saw so many applications of computer graphics in our module one. First is defining graphs as well as charts, and drawing graphs as well as charts there. Then entertainment. I need not tell you this again. You people remember, I guess. So I'll just be briefing out these applications. Then computer aided designs, virtual reality environment, virtual reality in the sense sitting in the same place and seeing, like you are just moving to the another different places by sitting in the same place. You feel like you are moving. That is nothing but virtual reality environment. This whole thing is the greatest application of computer graphics. Then education and training. There are many applications which are being used in education as well as training. Suppose if we take the example of our SWAS, which is nothing but D. If suppose you want to mark attendance or the shortage of attendance of that particular student, you, with the help of this application, you can do it, which basically consists of all computer graphics itself. Then computer animation, as I said, the whole television or the movies which you watch, like for example, the Bahubali series, it is full of animation, right? That is one of the example of computer animation. Then data visualization, which is nothing but plotting of your graphs as well as charts so that you can visualize that data in the pictorial form. Then image processing. This is one of the most important application in computer graphics, where a particular image is being processed so that the impurities which are being present in that image are being converted to the purest form. Then graphical user interface. The best example for GUIs is nothing but your Windows 10, where if you particularly click on a particular icon, you can access a number of applications with respect to that particular icon. So these are some of the applications of computer graphics. Then, as I explained you in the class, like these are the definitions of that particular app. Let's move on to the next topic, which is nothing but video display devices. As I told, video display devices, basically they are known as output devices. These devices you use to display the output onto your screen. Whenever you process some of the code as well as some of the application in your system with the help of some programming language, you require some output to be gained onto your output screen. So you use video display devices here. The most commonly used output devices in graphics system is video monitor. So let's see how this video monitor as well as video display devices work. First, let's see the types of display devices here. We'll be using cathode ray tubes here, which is nothing but you can call it as CRT monitors. There are two types of CRT monitors in video display devices. One is raster scan as well as random scan. These are some of the two types which are being included in your syllabus. There are still more, like LCD monitors are also there, but it has not been included in your syllabus. It was there for the previous scheme, but in this scheme it has been excluded. So only you need to study two types of devices. One is raster scan as well as random scan in the module 1. So let's see how CRT monitors work. First, the operation of most video monitors is based on standard cathode ray tube design, which is nothing but CRT. Basically, in the module, whichever the devices you study, which is nothing but random scan as well as raster scan, these two devices are dependent on CRT design, which is nothing but it opts the CRT design here. So let's see how basically CRT monitors work. This is the basic working I'll be telling, a revision of CRT monitors. This is the pictorial representation of CRT monitors. So first you'll be having connecting pins, or you can say connector pins. These pins are basically used to plug in your device to the socket where the current is being passed. There it consists of a base, which with the help of which you can store the electricity here. Here the electricity is being stored. Once you switch on the plug, the electricity is passed to this base where it consists of electron gun. Electron gun, the use of electron gun is nothing but it basically produces electrons. Once the switch is on, this base or this base basically consists a rod where the rod is being heated up. Once the rod is being heated up, the electron gun gets activated. Once the electron gun is being activated, it starts producing the electrons. Then you will be having some systems called focusing systems. Focusing systems, in the sense, it basically tells you that whenever the electron gun start producing the electrons get scattered throughout the device. So focusing system just focuses whatever the electrons is being produced from the electron gun to a particular direction. That is nothing but, as in the diagram, it is giving a straight path for the focusing, straight path for the electrons with the help of focusing systems. Then you'll be having two plates. You'll be using two plates here. One is horizontal deflection plates and the other one is vertical deflection plates. This basically represents the electrons. If you're using horizontal deflection plates, this directs the electrons towards the phosphor coated screen. If you are using vertical deflection plate, this will be giving the electron towards the last of your monitor screen. Then whatever the screen or the CRT monitors we have, it consists of a coated screen which is of phosphorus, with the help of which the display is being clear. And then whatever the electron it is being passed, it is being focused on the screen as in the form of electron beam. With the help of this electron beam, the whole picture or the video is being displayed onto the. So let's move on to the two types of our video display devices. As I told, these are some of the explanation of CRT monitors, vertical as well as horizontal plates. As I told, it is being used here so that the reflection of electrons is being passed onto the output screen there. Then there are two techniques used for producing images on the CRT screen. One is random scan or raster scan. Do remember, random scan is also called as vector scan. If in the exam, if they ask, explain the difference between vector scan and raster scan, please don't confuse yourself. That is nothing but random scan as well as raster scan. Clear? So let's move on to the raster scan. Basically, a random scan is not much used. Basically, the simplest form of scanning operation is used, which is nothing but raster scan. As the first definition tells, the most common type of graphics monitors used is raster scan display, which is based on television technology. I guess you people have seen the old TVs, or you can say old monitors. Basically, what it consists of, it basically had some doom kind of structure, right, for displaying of the output. So that is nothing but raster scan. Those are the raster scan devices, which are also called as video display devices, which use the technique of raster scan here. What happens in the raster scan? In a raster scan system, the electron beam is swept across the screen, one row at a time from top to bottom. Clear? If suppose, as I said, what is a picture? It is nothing but collection of pixels, right? So how the working of raster scan happens is, the electron beam, whenever the electron beam is being produced from the electron gun across the screen, it will take one row at a time. Suppose if you want to draw a triangle there, first row, the first pixel is been swept. In the second row, the two pixels have been swept. Each time, each row is being taken. So suppose each row is referred to as scan line. So once it starts scanning, it will consider each row at a time so that it can draw a picture as well as video onto the monitor screen. So as the electron beam moves across a scan line, the beam intensity is turned on and off to create a pattern of illuminated spots. Then frame, what does frame means? It basically refers to the total screen area. If suppose this is my system screen, this I can call this as one frame. That is nothing but total screen area. So as I said, one row at a time. See here, once the electron gun starts emitting the electrons, an electron beam is generated. It is being generating one row at a time. Finally, it will draw an object of a triangle here with the help of raster scan. Then these are some of the definitions of raster scan which you need to remember. Then it also consists of a memory there. A previous one, which did we study? Raster scan itself. Okay. Then there is some of the terminologies in it, which is frame buffer. So if we ask what is a frame buffer, you need to define the frame buffer as picture definition is stored in a memory area called the refresh buffer or frame buffer. This is nothing but a memory with the help of which you can store images or something. This is kind of a buffer which you need to keep into your system so that it can track the image there. What does this memory does? The memory holds the set of color values for the screen point so that it can display the whole part onto your display screen, which is nothing but raster scan. This basically frame buffer comes in raster scan. So do remember this. Then some of the examples of raster scans are home television, printers, etc. I guess you people have seen this old television in your olden days when you were kid, I guess. Yes, no, you people have seen this kind of monitors. Didn't see this kind of monitors. Basically, these are nothing but the olden days systems which you have been seen, I guess. The screen of the monitor or the TV will be this kind. It is being dome shaped. Fine. These are some of the examples you can give as home television as well as printers for raster scan. Then there are some more terminologies which you need to remember. One is resolution. I guess you people know resolution in an image. It basically refers to the number of pixels in an image. This is the simple definition of resolution. So when can we identify the resolution? Basically, you give width as well as height of an image as resolution. If you remember the width as well as height, you can tell what resolution is. Then there is something called aspect ratio. It is nothing but the number of pixel columns divided by the number of scan lines that can be displayed by the system, which is nothing but the aspect ratio. Then there is something called as bitmap. What is bitmap? Whenever a frame buffer which consists of 1 bit per pixel is basically called as bitmap. Thank God. Then let's move on to the next video display devices, which is nothing but random scan. It is also a CRT device, that is nothing but cathode ray tube device, which has electron beam directed only to those parts of the screen where a picture is to be displayed. In what happens in raster scan, it basically used to take one row at a time, right, while scanning. But in random scan, the electron beam, it is directly projected onto the screen where you can display the device, where you want to display the image or a video onto the monitor screen. That is what the first point tells. And then how the pictures are generated in random scan. Pictures are generated as line drawings with the electron beam tracing here. What does random scan do? It basically, these monitors are also referred as vector displays, which is basically called as stroke writing as well as calligraphic displays. These basically are used in the hospitalities where scanning like x-rays and all is being done there. So we'll be using random scan technology there. Then there are some of the definitions, that is nothing but what are the display of component lines of a picture can be drawn and refreshed by a random scan system in any specified order. But in raster scan, it used to opt top-down approach. But in random scan, there is no kind of approach. It starts displaying the device whenever, wherever it wants onto the display screen. But it depends on the electron beam, how it is being projected onto the output screen of the video display device. A small example of random scan is a pen plotter, which is nothing but it keeps on printing the image or the drawings which you want to do onto a screen with the help of pen plotter. Once you keep the device onto the screen or onto the sheet where you want to print, it keeps on printing until an entire image is being displayed onto the sheet. So it is one of the example. And then one more, you can say hard copy devices, that is nothing but your Xerox machines there. So these are two video display devices we studied. One is random scan as well as raster scan. The difference between these I'll be sharing in notes, so you people should refer the difference there. So next we studied the software, which is nothing but OpenGL. I guess I have covered all these in the OpenGL software. First, we studied introduction to OpenGL, then some of the coordinate reference frame, then specifying two dimensional world coordinate reference frame in OpenGL, then point functions, line functions, point attributes, line attributes, and curve attributes. Then with respect to these functions as well as attributes, we studied some point line attribute functions, with the help of which we started studying the two algorithms, which is nothing but line drawing algorithm as well as circle generation algorithms. So let's start. I'll just keep on briefing the topics here. So do concentrate. If you people have any doubts, you can stop me at any time and ask me the doubts. Okay. So let's see what is OpenGL. OpenGL is a graphics rendering API, which is nothing but a software which is operating system independent, Windows system independent, and has high quality color images, which is composed of some geometric as well as image primitives. You can simply remember that OpenGL is an free rendering graphics software with the help of which you can draw or you can project some kind of images onto the screen. There are some of the APIs which are being used in OpenGL. One is GL, GLU as well as GLUT. What is GLU? It is nothing but an utility which is used in OpenGL. What is GLUT? It is nothing but utility toolkit, which consists of the tools with the help of which you'll be drawing images as well as projections onto the screen of your monitor. Then OpenGL, what does OpenGL consist of? It consists of some of the basic functions which is being used in the software. What it consists of GLU, it basically has some utility libraries. And then what it has GLUT, it basically consists of a toolkit library with the help of which you can start executing as well as coding the coding some kind of images which you need to be displayed onto the screen. What does GLU as well as GLUT consist of? It consists of some of the functions for weaving as well as geometry. Suppose if you want to weave 2D object as well as geometric object onto the screen, we will be using these libraries, which is nothing but GLU as well as GLUT. Then OpenGL basic library. It is a basic library which consists of some functions which are being provided in OpenGL so that it can specify some graphics primitives, attributes, transformations, and so on. These are some of the operations which this OpenGL basic library does. What is the syntax of basic OpenGL library? First, the function name is being given with the help of basic library, which is also called as OpenGL core library, which consists of a prefix GL. Then each component word within a function name has its first letter capitalized. See here, when you people had come to lab when you were executing, I saw you people entering the commands very wrong. You people give GL space small b GEIN. This doesn't happen. You will get an error for this. So the command should be in one format, that is nothing but small letter GL, then whatever you start after this two letter, which is nothing but basic library GL, you need to start with capital letter. Please, if you have done mistakes while writing in the class, please do correct it. You whatever you use after this small GL, that is nothing but basic library GL, the whatever the alphabet you use, it should be in caps. Do remember this. First function, some of the naming convention I use here is GL begin, clear, copy pixels, polygon modes. These are some of the commands which we'll be using in the program there. That is nothing but these are some of the basic libraries of OpenGL. Do remember the syntax for basic library of OpenGL. First two letters will be small, which is nothing but small letter GL. Once you finish writing small letter GL, the next alphabet should be in caps, which is nothing but capital letter B. If you are writing GL begin, B should be capital letter in that particular command. In OpenGL basic library, there are some functions which require many arguments. It might be one or many. Such I can represent them as parameter name, value of a parameter, or a particular mode. All such constants begin with uppercase letter GL. If suppose you are passing some parameter to your function, so that command should be starting with capital letter GL there. See, suppose that as GL begin of, it is one function, right? After GL begin, you want to pass some parameters. So that parameter should be in capital letters. So for example, GL2D, which represents 2D objects, GL RGB, which represents the color of the object, polygon type of projection you are doing, and this ambient as well as diffuse, the type of polygon structure you are using in your program. So this is also you need to remember. Then, as in every programming languages, we have some data types. Even in OpenGL, we have some data types. One is byte, short, int, float, double, and boolean. The size of each data type is automatically stored, or you can say default into your system whenever you install the software there. For that also, check out the syntax. The first two letters which you'll be using is of caps, and then what are the next you are using, it should be in small letters. So to brief out some of the syntax in OpenGL for functions, this is the syntax. If you are using GL begin, the first letter should be smaller and the next letter should start with the caps. That is nothing but GL begin. If you are using GL clear, this is the syntax, and GL vertex. Then if you are using constant as the parameters for the functions, so this is a syntax, GL2D, GL line, so on. The data types which you use in OpenGL, GL byte, GL int, GL float. These basically we use only three data types, but the syntax of these data types is as follows. Then let's see some functions, so that with the help of these functions we can start weaving as well as projection matrices. These functions basically used to weave a particular object and start projecting that object onto the screen. As the definition of this function says, the OpenGL utility provides routines for setting up weaving as well as projection matrices, some of displaying complex objects with line and polygon approximations. Suppose if you want to display some quadratic as well as lines onto the screen. With the help of this command, you will be defining that particular object onto the screen. If you want to display a line onto the screen, you will give GLU Ortho 2D, which is nothing but you are displaying a two-dimensional object onto the screen with parameters 0, 200, 0, 150. This I can say x1, x2, y1, y2. This is nothing but the starting end as well as dead end of your object or the line which you are being displaying. This basically represents the starting and ending, or you can say height and width of your particular object or the line which you are using there. Then let's see what GLUT does. It basically provides a library of functions for interacting with any screen windowing system, contains methods for describing and rendering quadratic curves and surfaces. It basically, the prefix of this GLUT starts from small GLUT, which is nothing but the prefix of this library function. If suppose you want some of the more information about this toolkit, the website name or the URL is being given, you can just note down this URL and go and search there if you want more information about this library. Then let's see what are the header files which we use in your program. We'll be using three kinds of header files. As I said, we'll be using these libraries here. With respect to these libraries, you will include this header file, which is nothing but gl.h as well as glu.h. If suppose you are installing some software in the Windows and executing the programs in Windows as well, you will be using windows.h there. If you have downloaded OpenGL software in Windows and you are executing the programs with the help of OpenGL software in Windows, you will be using this header file, which is nothing but hash include windows.h, or else this is not necessary to include. And how the initialization is done with the help of GLUT, which is nothing but utility kit. First, as I said, the beginning of the command should be in smaller letters, which is nothing but GLUT, and starting off the another command, that is nothing but the function, which is nothing but initialization function in it. It consists of two arguments. One is argument count as well as argument vector. Suppose you want to display an window to be created on the screen with a given caption of the title bar. You will be using this command glut create window, which is nothing but naming of your window, an example OpenGL program. And how to specify the display window, what it should contain. Suppose in the previous slide you gave an example of OpenGL program. So what you want to display onto the screen or the window. So you will use this command glut display function line segment. This basically tells you that you are defining a line onto your window or the screen. But what if there is an exception there? What if the display window is not yet onto the screen? We use one more function to complete the processing of the window operations, which is nothing but glut main loop. What does this glut main loop does? It basically displays the initial graphics and puts the program into an infinite loop so that it keeps on repeating and display the window onto the screen. Well, this happens when this basically ends till you press a keyboard, any key in the keyboard or a mouse key there. Then there is another function we use, which is nothing but glut init window size. This basically defines the size of the window, which is nothing but length and width of that particular window. If you define 400 as well as 300, 400 will be the length of the window and width of the window will be 300. So these are some of the additional functions which we use. If you want to display or if you want to tell what kind of coloring you will be doing for the application or the object which you are defining onto the screen, you will be using this command, which is nothing but the mode of the display. It should be of this color, which is nothing but RGB, and some of the arguments. What kind of arguments you are using? You are using single arguments there with the help of this command there. So these are nothing but the definition of that particular command for giving RGB color. Then you will be clearing the buffer. First, check here, clear color command assigns a color to the display window. It does not put the display window onto the screen. To get the assigned window color displayed, we need to invoke the following OpenGL function. If you directly give GL clear color, this doesn't go and clear your background or your screen with the defined color. With the what you want to use so that you will get the color, you should use this command, which is nothing but GL clear GL color buffer bit. Basically, you pass an argument to this. This is a function, right? You are passing the argument to this function. The argument GL color buffer bit, it is an OpenGL symbolic constant which specified that it is a bit value in the color buffer that are to be set to the values indicated to the clear color function. If you define this function directly goes to the GL clear color function and checks what is the color is being specified by the user there with respect to R, G, and B value. Then this is the whole code which is being represented as I explained in parts. This is the whole code if you put in one statement and put. See, so suppose as I told the background color, I have defined RGB, all the three colors, then matrix mode, the type of projection you are doing, which basically sets the kind of transformation you use, and then the size of the object you are defining there. Then to clear the background, as I told you, will use GL color buffer bit. And then to set, if you want to set the object color as red, you give RGB value where R is 1, and then you'll start drawing the lines there with the help of vertex 2i. This basically a vertex 2i, it tells you the kind of index you are using there. This might be 3i also, which is nothing but GL vertex 3i, GL vertex 4i, so on, where the parameters keeps on increasing or as well as decreasing, which basically differs as well. After giving GL begin GL lines, you will start drawing a line where first point of the line will be 180, 15, and the second point will be 10 or 10, 145. This is nothing but representing the size of your point. Then GLN, once you give this command, the line will be displayed, and then the whole command is been, or the whole output is been displayed onto your output screen. This is the example. If you execute that particular code, you will get this kind of line onto your. I don't know after that. So let's see some of the callback functions which we use in the OpenGL. We have some callback functions which are called as event-driven, where these are being used in the programs that use windows, such as input and output. These event-driven callback functions, it basically wait until an event happens and then execute some predefined functions. So this happens whenever the user gives input. It keeps on waiting for a particular event to be looped up, and then it starts executing those particular commands. Some of the examples of events, suppose key press from the keyboard, mouse button press and release, and then window resize, etc. These are some of the examples of event driven, which where these programs wait until you press a key from the mouse or from the keyboard, etc. These are some of I can say event driven callback functions. Then as I said, the OpenGL program will be in the form of infinite loop there. Then some of the callback functions which I can define is glut display function, glut idle function, glut keyboard functions. These are all some of the event-driven functions which we use in the OpenGL. Then there is one more concept called event queue, where, as I said, event queue, if suppose there are 3 events happening, one is keyboard event, mouse event, as well as window event. This in event queue, this doesn't happen all at once. It keeps on executing one by one. Suppose if you press a mouse button, it will execute the mouse callback functions. Then after you press keyboard key, then it is still executing the mouse callback functions. So it will keep this keyboard function or the key which you have pressed in hold or in queue. Then it will, once the mouse callback function is being executed, then this keyboard or the key press callback function is being executed. That is nothing but one after the other. I can see this event queue is as the first come first serve function, where it executes the callback functions one by one there. If suppose all the three events have been pressed at a time, it checks the time at what time the event is been happening, and then start executing each callback functions one by one, which is one after the other. That is nothing but event queue. Then some of the coordinate reference frame. These, if you want to describe a picture, we'll be using some of the coordinate reference frames such as world coordinate frames, which is either two-dimensional or three-dimensional. To describe the objects in our picture, we give some of the world coordinates to the display object. So this is the world coordinate as well as device coordinate. If suppose this is the picture you want to, you have been captured, but you don't want this whole picture, you just want to display this picture with the help of viewport, you will be defining that part of that picture which you need. Where I have defined the whole picture in the form of minimum as well as maximum with respect to x and y axis. This basically is also called as weaving as well as clipping, which we'll be studying in further modules. Then in coordinate reference frames, there are different coordinates. One is screen coordinates, where in screen coordinates, basically pixel positions are being formed from top left corner of the screen. From, if suppose this is the screen I want to display, from this side, that is nothing but left part of your side will be processed as the first screen coordinate. Then there are some hardware processes which happens in this concept, that is nothing but the processing of the top left screen. And then in what if you give some software commands where you can set up any convenient reference frame for screen positions. If suppose this is the screen you want to print, with the help of software commands using coordinate reference frame, you can display this kind of object onto the screen. Then one pixel position in coordinate reference frame, there is something called as pixel positions which are being identified for an object. So how to use this pixel positions, how to set these positions so that it can reflect your object onto your output screen. We'll be using a command called set pixel x comma y, set pixel x comma y comma color, which basically this is setting of that particular pixel. If you use get pixel is nothing but you will get that kind of pixel onto the screen. And we'll be using GLU ortho 2D command functions where we set up any two-dimensional Cartesian reference frames there. Then another, what does this GLU ortho 2D function does? It basically specifies what kind of projection, which is nothing but, as the function tells you ortho, this is nothing but you are using orthogonal projection there. So some of the commands for using for projecting orthogonal projections are this. One is matrix mode, which displays the kind of product projection, and then orthogonal 2D, it is displaying a two-dimensional image where the minimum as well as maximum size of both the coordinates x and y are being displayed with displayed with the help of this command as an arguments. So suppose check here, this is the x min, x max, y min, and y max, and this is the display window you want to see onto the video screen. With the help of the previous commands, you can do this. Then as I had used one command called GL vertex, what does it do? It basically gives a call to GL vertex functions which are being placed between GL begin function as well as GL end function, which is nothing but we use, if you want to pass a single position argument to a function, we'll be using this GL vertex command to it. Check here, as I told, this GL vertex command has its own format. GL vertex 3 FVV 3 basically tells you the number of components you are using in the function, which is, if you give 2 here, x and y value should be given. If we give 3 number of arguments is being passed as and components to it. Then F, this basically tells you the what kind of data type you are using. In this command, you are using float kind of data type. If you give 3D, it basically tells you are using the double type of data type. Then we have something called as vector. This basically converts whatever the input you give with the help of whatever the input you give, it will be in the form of scalar form. With the help of this command v, it basically converts it to vector form. Suppose the whole command I can write as gl vertex 2f. This is basically optional in some of the programs. You need not use this. If you are just passing two kinds of components to this, you will be using 2f, which is of kind float, and the two parameters will be passing is x and y.